Well, hello friends. Today we are going to start building a JavaScript engine for Serenity, and we'll be starting from nothing. So I guess we will just make a new directory called lib.js, and in there, let's see what we put. Let's have something called an interpreter, and maybe an AST. We'll call it maybe nodes, or AST is fine, maybe. And we're just gonna cut straight to the chase here. We'll need some kind of a value class, and maybe an object, and also a little test file to run this. Actually, we can put that test file in the userland directory. And we will make sure that userland now depends on lib.js as well. Okay, and finally, let's just grab some simple makefile from another directory, or another library, rather, and copy that here. So what did we have? At object, interpreter, AST, and I already forgot what I put. Oh, maybe that was everything, actually. Okay, so let's start with those. And we'll see what we can figure out, because I feel like it's time we start building this thing. And people often ask me, like, how do you start building something new? How do you start from scratch? And I always give the advice to start with the thing that seems the most interesting. So that's what we're going to do now. So the thing that seems the most interesting to me is, at this moment at least, is the interpreter part. And just walking an AST and interpreting it to sort of affect a virtual machine state. So that's what we'll be doing first. Someone else might say you should Lex first and then parse and so on, but we're just going to jump straight to the AST. So here we have our thing. So let's just start fleshing this out. And we'll start with something, we can call it maybe AST node. And we want that to be protected. And this is just going to be our base thingy, base class. So we'll do something like that. And then we can say that each one of these guys has a, not static, virtual const char class name. This kind of thing is always useful, especially when you're building new stuff. You're just gonna ask what something is. And I guess to execute a node in our interpreter, we'll have something like so we can pass it the interpreter like this, maybe. Does that make sense? I feel like maybe it does. Okay. And then let's make a forwarding header. So I should have thought of that. Just somewhere to declare, forward declare stuff. Okay, so class value, class interpreter, class object. Maybe we can just start with those. Okay. So this will be our humble base class AST node. That's pretty good. And we are just gonna look at something, we're just gonna let someone parse some JS for us. So we'll use like Esprima, written by the famous Aria. How do I get to the thing? So Esprima, I remember they have this thing here, like this online parsing. So we can just write in a program, something like this, and oops, we can just say 1 + 2, right? And make a call statement that calls it. And over here, we can see the program that this results in. Apparently, we can't see it as a tree because the website is broken. Well, it's not my fault. Okay, well, we can see it as JSON, so this is good enough for me. So we're just gonna take a little shortcut here and use the same sort of parse tree that they, or the same AST and names that they have, just because that will be a bit easier. I don't have to think too much about that right now. So let's see what kind of nodes that gives us. Program node. And I guess we can define or declare these soon enough. I'm just going to add them one by one here. So we need a block statement, a return statement, a binary expression, and a literal. Interesting. All right, well, we can do that. Oh, and then we have expression statement. An expression statement. And a call expression. Yeah. So this might not perfectly mirror the Esprima AST because I'm not really sure how this tree hierarchy here works, but we stole the names, and I think we'll be good with that. We don't have to think up our own names for these things. And then let's produce one of these trees. We want to produce this same tree we have over here so we can play with it, or use it for testing rather. So in our little test program, we'll just do include AST. We'll just grab everything. Okay, so let's build the AST. Program. Should probably grab non-null encoder. All right. So what do we want here? We want a program with a function declaration inside of it. I guess program has a bunch of children in his body, so maybe we can invent some sort of a scope, like an executable scope node, maybe. This will be like something that you can enter, basically. And then we'll say that program is a scope node, block statement is a scope node, and these other guys are not scope nodes. And then we'll say that scope node can also have a protected constructor. And we can give him children. So non-null encoder vector of AST nodes. And we'll make this public. No. Okay, I'm having a little typing difficulties today, apparently. I think we want our AST to be generally const. We don't want to mutate the AST, so we just parse it, and then we want to have an interpreter object that just walks the tree and then changes the state of the virtual machine as it goes. That's the goal here. So let's see how far we can get. I guess if we can sort of make this AST and dump it out and then run it and get the right result, then I will be happy. So let's try to get to that point. And I'm just thinking, what am I going to add to all these things? Let's make sure we have these guys. Program. Not the most glamorous part, adding these introspection thingies, but it is useful. Private binary expression. I have never written a programming language before, by the way, so if I'm doing a whole bunch of silly things, then just bear with me. I promise I will learn how to do this as we go. Call expression. So, I mean, this guy is not inheritable, so, I mean, he's only inheritable. You can't instantiate him because he has a protected constructor, so he doesn't need class name, I guess is what I'm trying to say. All right, so now that we have these, and then we can make our function declaration. Did I not? Oh, I didn't make one of those. Dang it. Okay, well, we'll get there. Function declaration, public. Is a function declaration a scope node? I don't think so. Because the job of a function declaration is really to like instantiate a function with a specific name and add that to the global object namespace. So we'll just say he's an AST node. And actually, let's see what would we add to him. Function declaration. So over here he has a name foo, right? So let's make this simple. Just say return m name, and simple enough, right? I guess we need to actually include ActString. Okay, now we can create one of these guys. Call him foo function declaration. And we want the function to have a function has a body and parameters, right? Parameters. Oh, let's not care about parameters right now. We can do that later on. Let's only care about this. So I guess body is something that's common here between function and program. So I guess maybe that's that's what I've been calling a scope node here. So we'll put a scope node inside of the function. And this will be the body. Okay, non-null opener, scope node, body. All right. And scope node. Okay, moving pretty fast maybe, but I feel like this is all pretty straightforward stuff so far, at least. All right, so we'll set that up, and then for program, we want essentially the same thing for the body, right? We want to have a body, and we want to have a constructor. So program null opener to scope node body, make that explicit. Okay. And so now we need to actually make the body before we can construct these guys. So this has to go sort of deep. We have to go deep depth first or whatever. So at least when constructing. So let's see. So we want to create the function declaration, which needs to have body, and the body needs to have these nodes right here. Okay, so block statement, and that's just this block right here. And it's a scope node that you can run. Maybe there's not much more to it than that. We'll add a constructor for it regardless. All right. There we go. And then block, append. We don't have a way to append anything. Okay, so append child, append. Maybe we'll even do it this way. Append. Okay, I always forget how to do this. I gotta cheat and look it up. Okay, so it's args and args amp dot args, right? And then finally it's auto child is make t forward args and dot. Okay. One day I'm going to memorize that, but apparently not today. So we'll append that, and maybe we should return the thing actually, so you can modify it. Return mchildren.last. All right. So in this block, we want to append a return statement. And what goes into return statement? An argument. Okay. Return statement has an argument, and the argument is essentially an expression that tells us what we're going to return, like the value. So you evaluate the argument expression of the return statement, and that gives you the return value. So we'll say that, I guess we can do something like this. Like AST node, X argument, call it. M argument. This is a little backwards here. It's kind of, maybe I went a little overkill with the templated append. We can also just do this the other way. Don't have to overcomplicate things for ourselves. Set argument. At the same time, wait, how would I do this if I want it to be real fancy? Then I would just pass something like this, right? Return statement that takes an AST node and a non-null own putter argument. Okay. And we'll put that here. This could probably be more strongly typed, like it could be like expression something something, but we don't really have an expression type. I guess we could have if we just did something like that. Expression. And then we'll just say that an expression is a kind of AST node. And doesn't have to be anything more than that right now. Okay, just so that you can't pass any kind of AST node as the argument of a return statement. All right. Oh, wait, I had a call expression here as well. Expression statement. I have not looked at the JavaScript spec in years. I looked at it from time to time when I was working on WebKit, because sometimes you had to go in and like fix some little bug in JavaScript core or something like that. So I've been around JavaScript engines before, but I never wrote one. And I couldn't really explain how they work from like bottom up, but this is, I guess, my attempt to learn how they work by making one. So a return statement, and inside of that we're going to need an expression. We're going to put a binary expression. And inside of that, or I guess binary expression needs some metadata, so it needs to have like an operator, a binary op, just op. Okay. How about like plus and minus, maybe? We'll start with those. Binary expression. So we'll say you have to give it a binary op, and then you have to give it two sub-expressions, I guess, or like we can binary expression. I'm thinking like, should literal maybe be an expression as well? Maybe it's not an expression if you look at the definition of expression, but I'm not really sure what that is. So we're just going to roll with this, and then we'll say that you can have any expression here. And if I'm wrong, we'll change it later. So left-hand side and right-hand side coming right up. There we go. Okay, we'll say the op and the two sides. Okay, and expression. Okay, and then we just need a way to actually run this thing. So wait, right, I forgot how to define that. Okay, so this way. So we need to make all of our different nodes executable, essentially. So literal, when you execute it, it will just a literal is going to be like a constant, I guess. So this will just return itself, or its value, which we'll store here. All right. And something like that. And I guess we need to come up with that type. We're going to get there. Let's do it right away, actually. Namespace JS. Okay, so what is a JS value exactly? It has a type, and the type can be undefined, null, numbers, string, object, I think symbol, and am I forgetting one? Probably I'm forgetting one. JS value. JS value types. It's a Boolean. All right, what do we got here? Undefined null Boolean number big int. Well, we're not going to do big int right now. Probably not going to do symbol right now either. Function, that's interesting. All right, you know what? We'll skip on symbol for the moment, and we'll just go for Boolean instead. And we'll have a getter and type. By default, will be undefined. And then we need some construction helpers. So like, we can make one like that, I guess. Or, you know what, let's not allow that. And let's instead have some nice and friendly globals like Mama used to make in WebKit. Value type undefined. Okay, something like that. And what else? I guess we'll store the data in union, like typical multivariant data thingy. So for number, we'll need a double as double, and we'll need to have a string impl for the string, and as object, I don't know, bool as bool, some things like that. Okay, and we'll grab those guys, and we'll also grab these guys. Okay. I think we can just make a number constructor thingy. So double value. I did not name that. Okay, so value dot as double is value. Look at us. Something like that. And let's have a way to get them out as well. So we'll do like maybe double as double. This should probably assert type is type. And let's do a few of the other ones. So we should separate the concept of like as something and to something. So that's this typical thing that I often do, but I don't know if I ever mentioned it. But when I say as something, I mean interpret this thing as something. It's like a reinterpret cast. And if I were to say to double, I would mean take whatever the data is and static cast it to the thing that you actually want. So if you say to int, It's like, even if it's a string, all right, well, what if we try to interpret the string as an int through like string to int conversion? And if you said as int, you're telling it like, oh, this is already an int. So just take out the bits and hand them out as if they are an int already. Anyway, Boolean type number. Don't need that. Okay, so I don't have to fill in all of this stuff, but I guess we can start with that. Okay, and then we want to say here JS binary op plus. So this is going to be our binary expression, and it's going to have literal with the value 1, no, not block, 1, and the value 2. JS value is an incomplete type. Well, I'm sorry. Hold on. There we go. Okay, so now this constructs our return statement. And maybe we don't need to do it that way then. We can just do like block. Oh, this is the way I wanted to do it from the beginning. See, that's not so bad actually. Wow, this looks really neat. Okay, so that's our block statement. And then we just want to make that block statement the body of the program. So move the block into him. And then the function declaration. Wait, where was the function declaration? Wait. I'm confusing myself so much. I did not want to move that block into the program. The program needs its own thing. So a program is a scope node. So we could just append things to the program. Wait, a program is a scope node, but inherits from scope node? What was I even thinking here? Yeah, maybe we don't need to have a body if he already is the body. Okay. So we make the program, and then we say program append function declaration. And the function declaration should have the name. Wait a minute, it's already down here. Okay. Wow, this part is confusing for some reason. I don't know why. Okay. And then in that function declaration, we wanted the block statement with the return statement. That's where it was supposed to go. Right. It would be nice if you could write this all as like in the same style here. So how would we do that? That like program append, we make the declaration, and then we want to construct the block right here. It's a bit tricky because you want to add stuff and you don't know how many you're adding. See, it would sort of be logical to use an initializer list here, right? Because then you could like make the individual things that would go into the block. You would just implicitly create the block or something, but our non-null own pointers are not copyable, they're move only, so we're a little bit limited by that here, and the fact that initializer lists can't be, are not move only, so it's just something a bit annoying about C++ right now. But this is fine. Why can't I append this? Oh, because it works like this. Yeah, it's not so bad. Okay, so then after the function declaration, we also have the statement here that calls the function, so we shouldn't forget that. Expression statement, they call it. And it's going to contain one expression, which will be call expression. And it's going to be calling foo. Okay, so I think that's our program. Jesus. Took me a moment to write that out. So now we're going to need an interpreter, and then we'll just say interpreter run program. I guess for salt. And then finally, we can just print out the result. We'll print it on the debugger, actually. And return 0. Okay. Of course, we didn't actually make an interpreter, so we're going to need to make one. But let's do something simple. So what does an interpreter need? I guess he needs to be told what to interpret. So he needs to be constructible, first of all. Okay, and then we need to be able to run something. And we run a scope node, const scope node. Yeah, start with that. The JS forward. All right. And let's see, what else do we need? Wait, why is he not picking this up? Oh, I need to qualify. All right, and then, oh, right, we don't know how to stream JS values to debug output. We can fix that. Stream and const value. If value is bool. Wait, this isn't how we do this. We'll do it this way. Switch value dot type. Case value type boolean. And number. That's double, and we can't actually do doubles because the stream stuff doesn't support it. But it's going to be okay. Why are these things not compatible? Default break. We're forgetting something here. Ack log stream. All right. Sometimes these forward declarations can make things a little bit confusing, but I think we are good here. So we can do something like, or no, we'll assert not reached, because then we can add serialization of that value type when we get there. Interpreter returned result. All right, and then what does interpreter actually do when you say run? libjs. No, not namespace libjs. Scope node. Okay, so I guess we need to enter into the scope. So we'll just say like enter, we'll make some helper for that. We should probably keep track of this in some kind of scope stack. So we'll make a vector for that. And we'll do like scope frame, I don't know, scope stack. And here we can track the currently active scope node. I don't know if we'll need anything else, actually. Maybe this is enough. Or no, that's not enough. What am I even thinking? Because we're gonna need a place to store like variables and stuff that disappears after we exit the scope. So there will be definitely, we'll definitely need to store stuff here, but we don't have to make it super fancy right now. Just wanted to start fleshing out exiting and entering scopes. So we'll have something like that, like enter scope and exit scope. And then we should return something. So we can do that. So wait, what are we going to do here? So we're going to iterate over all of the children of the scope node, I guess. I cannot spell. Okay. And node execute this, something like that, right? And then we can do, we'll just remember the last value that we got. So something like this. Then we'll return the last value. Okay, so what's going to happen here is we call interpreter run with a scope node. Then we'll push that on the scope stack. I'll implement that in a moment. So we push it on the scope stack, and then we'll say the last value that we've seen was undefined. And then we'll walk all of the children of this scope node and execute each one of them, always remembering what was the last value that we got from an execute. And we'll pop the scope off the scope stack and return the last value. So I think this is obviously extremely simplistic, but I think maybe we can achieve this with a setup right now, at least. And of course, there will be a million things to support going forward, but we'll see. We'll see how we do each thing as we learn more about this. So let's see, interpreter enter scope. We'll just do something like that. And for exit scope, we will just take last. Maybe assert that scope stack dot last is the scope node. You don't like that because scope frame star. Oh, there we go. I guess there's no reason that this couldn't just be a const reference. Cool. All right, so that feels kind of good. Now, what are we going to do when we run each one of these things? So it's going to call execute. So we'll be starting at the program node and execute all of his children. So his children are the function declaration and the expression statement. So first thing will happen is this function declaration will be called. So function declaration. Let's just implement these one by one, do something sensible, and maybe everything will just work. I'm gonna try to implement this whole thing without compiling. Now I almost wish I hadn't said that, but we're gonna try. Function declaration. So the purpose of a function declaration is to add the function to the global object. And well, what is even the global object in this context? Well, the global object is, at least in a browser, it's the window object, and it's sort of implicitly where a lot of things end up. And we don't really have that concept here, but we did say that we should have an object thing, although I didn't make any object class. So before we can actually add it, because what I want to do here is like global object dot put my name, and I want to put a function object. A function, actually like a garbage allocated function, but we don't have a garbage collector, so we can't garbage allocate. So we'll just maybe we can even do new for now. So we want to do something like this. New function embody. Yeah. And then function should inherit from object as well. So I guess we have to actually make some kind of object class. But it doesn't have to be very fancy. So it will just be a property key value storage for properties. And properties is supposed to be sort of maintain order, but I'm just not going to care about that, and we'll deal with that some other time. So right now we'll just do something like this. Properties. Yeah, that'll be okay. And we need some headers, and headers go here. So ax hash map and lib.js forward. Okay, and then we need a get property name. And we also need a put property name, property name and a value. Notice how value does not need an argument name because it's obvious from the type name that it's the value, whereas here the argument name is necessary because you don't know, string doesn't imply property name, right? But value implies value. That's why it's like that. Okay, so this is pretty okay. And what would function look like? No, not this function. Oh, right, we need to JS function. Class function is a public object. And he can be constructed if you have a name and a scope node. Body. Name. Name. Okay, wait, let's put this out of line. Okay. Include act forward. Include libjs forward. Actually, we need object. And we need string because I'm going to store the string. Scope node, body. Okay, just adding some getters and stuff here. So this will be pretty good. And right now we're not caring so much about like the lifetime of the AST. Just assuming that it stays alive so we can keep these references to it. That's going to have to work a little bit differently later on, but right now it doesn't matter so much right now. So here we'll need to include libjs function and interpreter, I suppose. And we don't have a global object. Right. So what the heck is the global object? I guess we could just make it global. It's a bit gross. Let's store it on the interpreter for now, and then I think maybe that's okay. So we'll have an object that's like the global object. Yeah, can even be stored like that. Object, global object. And we can have a const variant of that as well. I think when we construct an interpreter, we'll just... Oh, we didn't make a constructor. I think we'll just make a new global object here, like global object, new global object, new object. Man, I forgot that we're gonna need to write a garbage collector. I forgot about that little aspect of JavaScript, but it's not a big deal. Of course, we're not going to do everything today, but we'll do a little bit. So we don't have to get fancy and delete stuff. We can leak it. Give us something to work towards, because we want to garbage collect these things anyway. Okay, so how does object do get and put? libjs object namespace. So let's just do the simplest possible. Object get property name. So return m properties. Get property name, value, or JS undefined. Okay, and for put, we'll do something equally simple. Property name, value. Property set, property name, move value. Right. We could even, I need to stop worrying so much about these things and get into this groove instead. I'm just warming up to the style of writing code, but it does look quite nice, and these are efficiently moved anyway, and they're reference counted, not copied. So, incomplete type ACK-string. Wow. There we go. Okay, so now we have get, put, and we have all of the things necessary. So let's go back to function declaration. Now we can say interpreter dot global object put. And then we need value to be able to wrap an object. And type object. Oopsie doopsie. Object, and maybe we'll have like object as object. Assert type boolean. What am I doing? You know, it would be nice if I could say is object instead of type equals type object. Let's add some of those things. Type is type undefined. So no number string object and a boolean. And who could forget? No. All right. Okay. And then now what we do here, when you execute a function declaration, we will now put a new function object with the name of the name from the function declaration. We'll put that in the global object. And I guess, should we return something here? Maybe we can do something like this. Auto function is, we can do it this way. Up, dang it. Value function. We can return it. It's not going to hurt anybody. Okay. So what other things do we need to be able to execute? So that's going to create the function declaration, right? And then we're going to need to run the expression statement. So expression statement. Seems like this guy needs value. So this thing needs execute. And I feel like this is just a thin wrapper around this guy. I'm not sure if we need the separate node. I mean, I'm sure Esprima does this for some reason, but I don't know what the reason is right now. So maybe we'll just simplify our AST at the moment. and not make that expression statement. And we can just say program append. Okay, that's a little bit simpler. Then we just need to implement execute for this guy. So how do we do that? Value, call expression, execute. So what we want to do now is we want to look in the global object and see if we can find the name that we're looking for. So call expression actually needs to have the name of the thing that we're trying to call. And name, I guess. Name. String name. Name mode name. Okay, and make that private actually, or Okay, so now we got to figure out where's the function with this name that we have. So we'll look for it in the global object. Callee is interpreter global object get my name. If Callee, we'll assert actually Callee is object. And then we'll say auto Callee object as object. Maybe we'll do this as well. And we'll have a way to, oopsie. We'll just have a way to say that this guy is a function. So virtual bool is function. Return true. And we might need something like, we'll put that out of line. We just need to make sure that we declare this const, return false. All right. Did I not even make a function CPP? Okay. Callee object has to be a function. Of course, these assertions are just because I'm not going to implement any of the other contingencies right now. So we're just going to assert that it is indeed a function. And then our function is static cast function is const function Callee object, or just function like that. Okay. And now what we want to do is we want to get the interpreter to run the function. So we'll just do like return interpreter run function body. Okay. And what comes next? So now we're running the call expression, hopefully calling this function. And by calling that, we'll start executing the children of this thing right here, or this body. So we'll get a return statement that we want to execute. So we're going to need to, I'm just going to do these incrementally like this. Okay, so return statement. And what did he have? He had like an argument. It's an expression. Okay, so a return statement. I guess you want to tell the interpreter something like do return, because you want it to sort of unwind up the chain of block or up the scope chain until you reach a function boundary, I think. I'm not exactly sure how we should do that, but we'll give him a signal here. And then we want to run the expression that we got, argument execute in the interpreter. Something like that. Why did I make that a pointer? Isn't it required? It is required. So it should be in one of these guys instead. See, then we can use a dot. Love the dot. Okay, so void do return and do return. I'm not exactly sure what we're going to do here, but we'll say fix me implement interpreter do return. All right, we'll do something clever, like unwind the scopes. Okay, so now we're going to execute the argument. So that's this guy right here, a binary expression with an operator and a left side and a right side. So we'll just need to implement the binary expression execute, which I already declared. Okay. And I think maybe we can, let's see, maybe we'll call them A and B, or LHS result is MLHS execute interpreter, and we'll execute the right side. Maybe there's some other way that you're supposed to do this, but I'm just going to do it this way, and we can learn later if there's a better way. And so we have the two results. Then we'll switch on our op case. What did I call those? Binary op plus and minus. All right. And I think here we can do like, oh, this is a little bit complicated because we need to add together arbitrary values, and we don't know what type they have. So let's just put that in a helper, like add LHS result, LHS result. Something like that. And we'll assert not reached, because you should have had one of those two ops. And we can just value add value something like this. And for now, we will be lazy and say that both of these are numbers. Value LHS dot as double. No, not its object. So yeah, we'll do this. And of course, it's not going to work for strings and stuff like that, but it doesn't matter. We are just here to implement enough to support this freaking program. I feel like I've been going for quite a while, but we're gonna make this happen. Am I ready to compile yet? I don't feel quite ready yet. So what's gonna happen now? So now we're gonna run the program. We're gonna insert the function declaration or this guy will create the function, okay, then we'll call the function, and then inside of the function, we will go through each one of these children. There's only one child, it's the return statement, and we'll execute it. And then how does the return value propagate? The return statement will propagate because it's the value returned from this guy, which what you call here, we'll call interpreter.run, and it's just gonna, oh yeah, right, so the last value, the last thing evaluated inside of the scope will become the return value, which is just kind of natural, right? And maybe that's not how JS is supposed to work all the time or something, but we'll learn that later. I don't know. I don't know all these like little specifics and stuff, but maybe this is not all bad. Am I forgetting something? I must be forgetting something. Okay, let's take our chances and see. Does this compile? Wouldn't that be nice? It does compile. Okay. And what about the userland part? Oh, it's a lot of stuff. Did we get a JS program? No, we didn't. Here it is. Okay. Oh, we have some abstract classes in the AST. That's fine. Program is abstract because it cannot be executed, I guess. Oh, maybe we need to make scopes executable. That seems doable. We can just do like that. And in the AST CPP, we'll say, we'll put this up top. Scope node, execute. When you execute a scope node, what we'll do is we'll just return interpreter run me. Run me. Okay. Okay, that cuts down a bit. JS return statement. Right. AST.h 29. Forgot to cast in my template helper here. Gotta cast the thing that we return to a tamp, and we should be good with JS. Userland. Oh, look at that relink. Okay, so what did we forget to implement? I forgot to say inline on this guy. That's my bad. We forgot to implement the function constructor. Forgot to implement anything in the function thingy. Okay, well that's not so bad. But we'll see if it runs, because I don't want to get excited yet. Was it scope node, body, name, move name, and body. Okay. Oh, right, we have to add it to here. Wait. Oh, this is not alphabetical at all. And you don't like that I did this because wait, where is this required? From hash map and instantiating the object. Oh, right, because it needs value. Userland, let's only do JS. Okay. All right, moment of truth. We'll see what happens. Ah, damn. Oh. Look at that. Interpreter returned 3. Well, that was the desired outcome. It's so undramatic. See, I thought it totally failed at first because there was nothing coming out in the terminal. Then I remembered I put it on the debugger output. So we made a program that can print 3. Very nice. So it takes this AST, runs it, and it produces the number 3. That's pretty cool. So what if we complicated it further a little bit, and what if you did something like that, right? What would that look like? Can you resize this guy? So you would need like a binary expression that has a binary expression inside of it. So so this guy, tap, 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 and a constant JS value 3. Oh, this looks so tidy when you auto format it with client format. It's very cool. So let's see if this can produce 6, because if so, we will have truly succeeded at something. What am I forgetting? I cannot do this because I am not providing an op for the inner one. Right, that makes sense. It returned 6. Dude, very cool. Okay. That's really awesome. Okay, gotta slow down a little bit and catch up with myself. Okay, so this is pretty neat. Let's see. Let's make something that prints out the AST before we run it, because that would be nice to look at. So I guess we can have something like dump AST program. AST node. Or wait, why am I putting that here? Let's put that inside of the node itself. Program dump. And we'll put it here. Oh right, it's not super straightforward how to dump these. We need to add some logic for that. So dump. Each guy would need to know how to dump himself. So scope node, virtual void dump. And well, this might be a useful thing to have, so we'll make these. Turn. Actually, we don't have to implement it on everyone. Only the ones that have children need to do something special. Everyone else can just do like we'll see what we do. Dump, override on the scope node, and then all the other guys except the binary expression. don't want to get carried away with this. So let's go in and look at the AST dump printf. Class name, right? And scope node dump. You know what? Scope node needs to walk its children, right? That's what we need. Oh, and we need an indent level for these things. Indent, right. Print indent, int indent. Bootchar, something like that. Okay, and then print indent indent. Okay. And then here we will add all of our children. So for auto child in children, child dump indent +1. Oh, dump needs to be const, that's for sure. Const. I should probably have done the dumping first. I was just in such a hurry to get something working. All right, so we have those, and then let's do the binary expression dump. I guess the left-hand side dump indent +1. And we can also say here binary expression, both print indent. Right, that's how these should look. Printf %s class name. Yeah. All right, I'm forgetting some, but let's compile so it tells me which one I'm forgetting. Dump at indent 0. All right. Forgot about call expression. I guess, how do we want this one to look? Dump indent. Printf, something like this, and like print the name of the thing that we're calling. So like this. Class name characters. Which one are we not having? vtable for JS literal. Oh shit, we forgot something. JS literal needs Oh, he has a dump, but he doesn't know how to dump himself, right? Maybe we'll do it this way right now. And value as double. Okay, this is a total hack. All right, will it work, I wonder? Well, we didn't go into the function declaration. Oh, we need to make a dumper for him as well. Of course, it needs to descend into its body. Function declaration dump. Last node dump. And we will just do a body dump indent +1. Okay, is this finally enough? Okay, I'm starting to catch up a little bit. Needed some more simple programming. All right, so return statement. I guess return statement should descend into its argument thing. So argument dump. There's probably a better way to do this, but it seems to work. Okay, now these don't look quite right. These are definitely not the right numbers. Binary expression, LHS and RHS. So for binary expression, we dump the left-hand side in both cases. That's definitely not what we want to do. Okay. So, is this our program? It's a program that has a function declaration. We could actually say what the function is called when we dump it out. Print indent. That would be kind of cool. You can see what function we're declaring. Okay. Look at that. Maybe print indent would look nicer if we multiplied it. Okay, and I would just like a way to get these things, turn them into strings. So let's have a way to do that, because it's kind of irritating. It's going to keep bothering us if we don't do this. I guess we can put it here. Do we have string? Yeah, we do. Okay, so no, wait, we don't have string. Okay, I'll add one more CPP file. I should probably implement something in that CPP file. Value CPP, refresh. Value to string. Okay, here it comes. So if type, if it is Boolean, turn as bool, true, false. Oh wait. I still don't have the ACK string. So did we have as bool? As bool. Oh, we did. All right. If is num null. Okay, yeah, we can do these. Null is undefined. Number. String number. I think for now we'll hack this and do as double like this. Fix me. This should needs improvement. And then we'll just assert not reached if we don't know what it is. Maybe if is object, we can do something like the class name. JS object. We don't have a class name there. All right, well, we'll have to add that. I think that would be useful to have. So object.h. Let's have class name. Virtual. Return object, and then everyone will have to override that as they please. Okay. And I still forgot to do something with it, so I keep forgetting. In JS CPP, I would like to print it out. Something like this. Resolved to string characters. And I don't have printf. Right. Very cool. Man, this turned out really nice. I'm sure that there are things about this that are not entirely correct and everything, but we'll fix those up as we go. I just wanted to get started on this. So I've been postponing starting on a JavaScript engine forever. And now we are actually doing it. So I'm glad that we're all here. And oh, we're gonna need to commit all of this. That's cool. Just grab some license header. Make sure that we do this right from the start. And we'll say 2020. You all saw me writing it. So, no cheating here. Man, this has been like standing in my way for a while because I've been having trouble getting back into working on the browser stuff because I always feel like, well, as long as we don't have a JavaScript engine, it's going to be a bit annoying to work on the browser anyway because you can't do X, Y, Z, right? I always have these ideas for dynamic things I want to do. But now we are definitely taking a step towards much more interesting browser work than we already had. So we're probably forgetting some files. That's the wrong file. Now we have JS function and ACK function. Let me just see. Interpreter. Okay, who else am I forgetting? Forward. No, not you. It's you. And maybe that's everyone. Okay, so libjs. Let's add it. And let's add use line.js. And use line make. And wait, let's look at this before we commit it. And just see if we are forgetting a license header somewhere. Gotta get those license headers. It's all nice and tidy. Oh, we forgot JSCPP. I knew there was one I was going to forget. Okay. So, lib.js. Start building a JavaScript engine for SerenityOS. I always tell people to start building things by working on the thing that seems most interesting right now. Today, the most interesting thing seemed to be, the most interesting thing today was the most interesting here was in AST plus interpreter. So that's where we start. There is no lexer or parser yet. We go directly build an AST directly, then execute it in the interpreter, producing a return value. This should be this seems like the start of something interesting. Let's do one more of those. We can afford it. All right, that's pretty good. So I guess it's going to be it for today's video. So I just wanted to get this started. So if you made it this far, then I thank you for watching. And I hope you saw something interesting. I certainly had an interesting time building this, and I feel like we went pretty fast, but I guess I knew where I wanted to go with it, so it turned out pretty okay. We're definitely going to keep working on this. This is just a beginning, but now we're started. So thanks everyone for hanging out, and I'll see you next time.